Okay, so let's have a look at section 6.3. We're going to graph a quadratic using x-intercepts. Now this should feel familiar because we did it in chapter 4, we did it in chapter 5, and we're doing it again in chapter 6. So hopefully if you had difficulties with it earlier, it's going to start making sense. First thing you need to do is find the x-intercepts. Then after we have the x-intercepts, we're going to find the vertex, and then we're going to sketch the graph. Okay, so you have to understand what you did yesterday. In order to find the x-intercepts, you need to factor this. Okay, so think to yourself, what does y equal at the x-intercept? Y equals 0. This is why your quadratic must equal 0, because you're looking for the intercepts, and y equals 0 at the x-intercept. This must be factored. So all those factoring techniques from chapter 5 comes back. So the first thing you always look for is a common factor. And do you have one here? No. So this is not a trinomial. Perfect square subtraction. So this is a difference of squares. So I factor it. So how do we factor differences of squares? Remember, you have two brackets. Square root the first term, which is x, plus sign in one, minus sign in the other, square root the second number, which is 4. Once again, it equals 0. Now at this point, you're going to let brackets equal 0 and solve for your x value. So I'm going to let each bracket equal 0. So x plus 4 equals 0, x minus 4 equals 0. Solve for x, make sure you change the sign. So there's one x-intercept. Move that over. There is the other x-intercept. So I can plot these on my grid. And so I'm going to, at this point, you're going to decide what scale and how much space you're going to go by. So I'm going to go by space of 1 and a scale of 1. So I plot my two x-intercepts. I have one here at, right here at -4, and the other one here at +4. You should know before you graph the direction of opening. How do you determine the direction of opening again? Remember, you look at the a value. If the a value is positive, like it is, it opens upward. If it's negative, it opens downward. So I know that this opens upward. If you find the vertex and you find that it's opening downward, that's a clue that you made a mistake, right? So now I've done this part. I found the x-intercepts. I'm going to find the vertex. Remember, the vertex, if this is because of the symmetrical nature of the parabola, it's going to be at the halfway point between the two x-intercepts. So once again, to find the vertex, you take your two x-intercepts and you add them together, divide by 2. So x at the vertex is -4 plus 4 is 0, divide that by 2 is 0. Okay, now I'm going to find y at the vertex. So I take this x value at 0. I could sub it in here and solve and make that equal to y, which I probably wouldn't do. I'd probably just go right here, and you could sub it in here, or you could sub it in here. It doesn't really matter, but I'm going to sub it in here. The value of y, I take 0, I square it, subtract 16, which I know is -16. So this is my vertex. X is 0. Y is -16. So now this is when I do my scale on y. I'm not going to go by 1s. I'm going to probably go by 2s. Okay. Okay. And then I'm going to plot my vertex at 0 and -16. So there's my vertex. There's an x-intercept. There's the other one. Then remember, you're going to don't connect, so it's your parabola, put arrows on both ends, and then of course you label it. Okay, just like that. Let's try one more. Okay, same idea. Again, you're going to make your quadratic equal 0 because you're looking for the x-intercepts, and you're going to factor it again. You always factor to find the x-intercepts. So you look again. Do you have a common factor? No. Now this is a trinomial where the a value does not equal 1. So we do this by the method of decomposition. So remember, we're looking for a product of 2 times -6, which is -12. A sum of -1 What two integers multiply to -12 but also add to -1? Those two numbers are -4 and +3. You add those, you get -1. You multiply them, you get -12. So remember, you take those two numbers and you rewrite the middle. So 2x squared minus 4x plus 3x minus 6 equals 0. Now look for the common factor between the first two and the common factor between the last two terms. So here, between 2 and 4, the biggest number that goes into both is 2. X squared x, present in both, lowest exponent value is x. Divide each term by 2x, I'm left with x minus 2. Remember, bring down this sign. Look for the common factor between the last two terms, which is 3. Divide each term by 3. Once you see your brackets are the same, you should feel pretty confident that you're doing it correctly. Okay, and so now it's been factored. So now, once again, we factor it, and then we let each bracket equal 0 to find the x-intercepts. And this is an example where one of my x-intercepts is going to be a fraction. So here, move this over. One x-intercept is 2. Move this one over. I have the other x-intercept being -3 over 2. If you want, you can change that to a decimal, so -1.5. Okay, so you're going to plot these two. So again, you're going to decide what scale you're going to go by and how much space. Now, because this is a decimal, I'll probably leave 2 spaces between my numbers. Just might be a little bit easier to see. Okay. So here I'm going to go to -1.5. There's one x-intercept and the other one right here at 2. Again, you should be thinking to yourself, what's the direction of opening? Is this going to open upward or downward? And because your a value is positive, you know it's going to open upward. Okay, now let's find the vertex. Once again, you're going to take your two x values, you're going to add them together, and you're going to divide by 2. So 2 plus -1.5, 0.5 divided by 2, 0.25. Okay. And then we're going to find what y is at the vertex. So you're going to sub it into your equation here and solve for y. So y equals 2 times 0.25 squared minus 0.25 minus 6, and then you're going to follow your order of operations and figure out what y is. So 0.25 squared, 0.25 squared is 0.0625. Okay, multiply that by 2. You get 0.125. Okay, and again, this is an example where our vertex is a decimal, so we get this as -6.125. Okay, so I know my vertex is at 0.25 and -6.125. And then you just do your best to estimate where that is. Okay, so on my y-axis, I think I'm going to go also by a space of 2. Okay, and I'm going to plot my vertex. Okay, so I'm going to, so if this is 0.5, I know 0.25 is halfway between 0 and 0.5, and then I'm going to estimate here at -6.125. Okay. And then I draw my quadratic, or my parabola, sorry, didn't do such a great job there. Arrows on each end, and then of course you label it. And now we are done.